Are there any questions on the homework before we get started? So what we're looking at today is solving. We're solving rational equations. Now, one of the first things we need to do in solving rational equations is to find the restrictions. Our restriction tells us what values of x it cannot be. And essentially, these restrictions are the values that are going to make the denominator be 0. Now, the two places that it can be 0 is x plus 1 and 4x plus 5. In neither one of these cases, we can have it be 0. Now, we've talked about restrictions a little bit at the start of the lesson, or at the start of this chapter, but we haven't talked about it too much since then. Restrictions. So for our x plus 1, we would subtract 1, telling us x is negative 1. So when x is negative 1, one of the denominators would be 0. So x cannot be negative 1. And this is helpful for when solving, because if we find a value of negative 1, if we solve it and we get an equation saying that x is negative 1, we know that it will not work. We can do the same thing for our 4x minus 5 by subtracting 5 from both sides, telling us 4x is equal to negative 5. Divide both sides by 4, telling us x cannot be negative 5/4. So if we did solve it and get a value of x equal to negative 5/4, we know it would not work because it would make one of the denominators be 0. So for today, these restrictions aren't going to come into play, but it is good to list them just in case they do come up. Questions on this here? Questions on either so far? Least common denominator is the next essential piece that we need in solving these rational equations. Now, we use least common denominator when adding or subtracting in our complex fractions, and we'll have it in a similar way. Now, when we look at these here, we do need the denominators, our x plus 1 and 4x plus 5 factored as simply as possible, or factored as far as they possibly can. Well, x plus 1 and 4x plus 5 are completely factored. There's nothing in common between our x and 1 or 4x and 5, so they're simplified. So now we can find the least common denominator. And one part of it is going to be x plus 1, and the other part is going to be 4x plus 5. Questions on these so far? We good with this here? Yes? Now, unlike addition subtraction, what we're going to do with the least common denominator is multiply every part of this equation by it. So we're going to multiply our 3 over x plus 1 by the x plus 1 and 4x plus 5. We're going to multiply our 9 over 4x plus 5 by our x plus 1 and 4x plus 5. And when we do this, we get 3 times x plus 1 times our 4x plus 5 over x plus 1 equals. We'll do the same thing with 9. We have 9 times our x plus 1 times 4x plus 5 over 4x plus 5. Let's go with blue. Questions on what we've done so far? We're good with this so far. Now, part of the reason we did this is because if we look at the left side, since it's multiplication on top, well, the x plus 1 and x plus 1 will cancel, leaving us with 3 times 4x plus 5. On the right-hand side, our 4x plus 5 and 4x plus 5 will cancel, leaving us with 9 times x plus 1. And that's why we did this multiplication as the least common denominator, to get all of our rational expressions to simplify out. Because now we have an equation that has no fractions left. Questions on this here? Question on anything we've done so far? Now we just need to solve for x. So the first thing we can do is distribute the 3. 3 times 4x is 12x. 3 times 5 is plus 15 is equal to, we'll distribute the 9. 9 times x is 9x plus 9. Send the screen once. Now, since we just have x, 12x and 9x, those are the only spots where the variable shows up. Well, multi-step equation, we're just getting x by itself. So the first thing we can do is what? Just 9 or 9x? We can subtract 9 from both sides. Because on the right-hand side, the 9 minus 9 would be 0, leaving us with 9x. We could have, yes. But for this time, we'll minus 9. Now we can minus our 12x. (12x minus 12x is 0. 9x minus 12x is negative 3x is equal to 6. And last but not least, we can divide by negative 3, telling us x is equal to negative 2. And that's it. And negative 2 is not one of our restrictions. So that's our solution. And for here, we only have one value of x. That will make these two be equal. Questions on anything we've done so far? Now, we don't have to do this. We can. I'm going to go through and check to make sure that negative 2 works. Because for the one side, we have 3 over negative 2 plus 1. The other side, we have 9 over 4 times negative 2 plus 5. Well, for the left side, negative 2 plus 1 is negative 1. 3 divided by negative 1 is negative 3. The other side, 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. And 9 divided by negative 3 is indeed negative 3. So both sides have the same value, telling us that our solution is indeed x equals negative 2. Questions on this here? Let's look at the next one. 2 over x plus 2 is equal to 10 over 3x plus 2. Our restrictions. So the two places where we can have a division of 0, one of them is x plus 2, the other is 3x plus 2. Well, with our x plus 2, we can subtract 2 from both sides, telling us that x cannot be negative 2. Because if x is negative 2, our negative 2 plus 2 would give us a 0. It would give us a restriction. Our 3x plus 2, we would subtract 2, telling us 3x would equal negative 2. Divide both sides by 3, telling us x cannot be negative 2/3. And if we got one of these two values, we would just cross it out and be done. Least common denominator. Well, the two spots that we have, x plus 2, 3x plus 2, neither one of these is factorable in any way, shape, or form. So our least common denominator would be x plus 2 times 3x plus 2. So what we're going to be multiplying both of these by is what? Well, x plus 2 and 3x plus 2. X plus 2 and 3x plus 2. Questions on this here? Questions on anything we've done so far? Now we can make this a little bit easier, a little bit simpler. Well, the reason we're multiplying the left side by x plus 2 is so that the x plus 2 and x plus 2 will cancel. And what that'll leave us with is 2 times 3x plus 2. We're wanting to multiply the right side by our 3x plus 2. So those will cancel, leaving us with 10 times x plus 2. Because again, we're multiplying everything by the x plus 2 and 3x plus 2 so that the denominators will simplify out. Questions on this here? Well, now we need to distribute 2 times 3x is 6x. 2 times 2 is plus 4. Our other side, 10 times x is 10x. And 10 times 2 is plus 20. Again, we don't have an x squared, x cubed. We don't have x to an exponent other than 1. So get x by itself. What can we do first? Minus 4. We can subtract 4 from both sides, telling us that 6x is equal to 10x plus 16. What can we do next? We can, but I would do something else first. Because if we divide by 6 at this point, because we would divide the 6x by 10, or 6, we'd divide the 10 by 6 and the 16 by 6. So I would wait to get the 10x, all the x's by themselves first. I would subtract 10x from both sides. 6x minus 10x would be negative 4x is equal to 16. And now we're going to divide it by negative 4. Telling us x is equal to negative 4. 6x, 10x, 16. Questions on this here? It's sometimes easier to just get the variable by itself first. Any questions on any of these here? We ready for the next one? Restrictions. Well, only two places where the denominator can be 0 is with our 5x and x minus 7. Well, with 5x, well, we can divide both by 5, telling us x cannot be, well, 0. And with our x minus 7, we just set it equal to 0, solve for x. So x equals 7. So when x is positive 7, we'd have a denominator of 0, and it will not work. Questions on this here? Questions on any of this so far? What would we need to multiply everything by? Because our least common denominator, what would we be multiplying everything by? Because 5x for sure, because on the right-hand side, the 5x and 5x would cancel. 5x is not going to do anything to the x minus 7, so we'd have to multiply also by our x minus 7 to get those to cancel. Now again, I kind of glossed over it, but the fact, almost, because it'd be 3 times. Because the denominator, we multiplied the 3 over 5x by the 5x to get that denominator to simplify. Then we're also multiplying that 3 by the x minus 7. Because when we do this multiplication, it's applying to the numerator only, and the like terms are simplifying out with the denominator. At this point here, we need to multiply through. 3 times x is 3x. And 3 times negative 7 is negative 21. And 2 times 5x is 10x. Yes, at this point we can. We would minus. Because since our 3x is positive, yep. So those would cancel, telling us that 7x is equal to negative 21. And what can we do last? Divide both sides by 7, telling us x is negative 3. Is that one of our 2 restrictions? No, so it works. And all the ones that we're doing today, the restrictions aren't going to come into play. They're not going to be a value that we get when solving. Questions on this here? We feel good with this so far? Yes? Okay. Restrictions. Well, x plus 3, x minus 3. I keep kind of glossing over this. I've done it all day. Are simplified. They're not factorable. We agree with that there. X plus 3, x minus 3 are not factorable. No greatest common factor between x and 3. No difference of perfect squares. None of our factoring methods work for those. So they're already simplified. For our restrictions, the x plus 3, we would subtract 3, telling us that if x is negative 3, one of the denominators would indeed be 0. So x cannot be negative 3. And 3 for the other one. Because if x is positive 3, one of the denominators would be 0. So we cannot have positive 3. Questions on this here? Questions on any of this so far? We feel good with these here. What are we going to multiply everything by? We're going to multiply each of these by x plus 3 and x minus 3. Now, we haven't been doing the full multiplication out like we did on the first one, but essentially that's what we're doing. Because the numerator is negative 4 times x plus 3 times x minus 3. For the ones that we have, no, because the 30xs and the 84 plus have to have a value for x. Well, we are multiplying, because when we cancel it out, really what we said when we multiplied is that we have negative 4 times x plus 3 times x minus 3 over x plus 3 is equal to 5 times x plus 3 times x minus 3 over x minus 3. Well, the first one here x plus 3 over x plus 3 is 1, leaving us with negative 4 times x minus 3. So just like the first one and all the ones we've done, we're essentially doing that step. But since we know x plus 3 over x plus 3 will reduce, and on the other side, our x minus 3 and x minus 3 will reduce, we can go on and cancel it out and jump to this step. We're just skipping that step. And from here, we can solve for the value of x. So the first thing we can do is distribute the negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3 is plus 12. 5 times x is 5x. And 5 times positive 3 is positive 15. Now this one here, just like all the ones we've done today, linear, we just need to get x by itself and solve. So what can we do first? We can add 4x to both sides, which will tell us that 12 is equal to 9x plus 15. What can we do next? Minus 15. And when we subtract 15 from both sides, we get 9x is equal to negative 3. So last but not least, we need to divide by 9. And negative 3 divided by 9 is 3, yes? Well, I hope it's not 3. 3 or 9. No, you're good. No, I said that intentionally. It was mean. But negative 3 over 9 would reduce to negative 1/3. It's not one of our restrictions, so that is our solution. Because our solutions don't have to be rational numbers. They can be, or don't have to be integers. They can be rational, negative 1/3. It actually works out they can be irrational. We can have radicals as part of our solutions, and it still work. Questions on these here? So again, I'm going to go on and just give you the restrictions for this one here. X cannot be negative 5/2 and x cannot be negative 8/11. Really, we're just setting both of those equal to 0, solving for the value of x. So looking at this problem, again, we need to multiply by the least common denominator. And our least common denominator, well, part of it is what? 2x plus 5. 11x plus 8. We need both of these here. Because on the left-hand side, the 2x plus 5 and the 2x plus 5 would cancel. And on the right-hand side, the 11x plus 8. 11x plus 8 will cancel. It's going to reduce this here. So on the right-hand side, we have x times 2x plus 5. What's left on the left? 1 times 11x plus 8, yes? That's kind of a nice one, yes? Because 11x plus 8, because 1 times anything is the other piece. Now, the right-hand side, we do need to distribute this x. X times 2x is 2x squared. And x times 5 is 5x. So this is the first quadratic we have, because we have an x squared term, yes? Whenever we get a quadratic, an x squared term, x cubed, where we have a variable with the exponent greater than 1, we have to get it equal to 0. Because all the ones we have had up to so far haven't had x squared, it's just been x. And those we get x by itself and the numbers by themselves. Here, we need to get this equal to 0. So the first thing we can do is subtract 11x from both sides, because this here will cancel, leaving us with 8. And give us 2x squared minus 6x. And then the next thing we can do is subtract 8, telling us 0 is equal to 2x squared minus 6x minus 8. Questions on how we got to this point here? We good with this so far? Now, if there is a greatest common factor that is a number, not a variable, but a number, here it has a greatest common factor of what? 2. We can divide that out. If it's just a number, we can divide it out and nothing is going to happen. It's not going to affect the overall function, because now it'll tell us that 0 is equal to x squared minus 3x minus 4. And one way I can show that is by, well, graphing it. Because our original was 2x squared minus 6x minus 8. And this is the graph. This is the graph of that function. Now, when we divided each of the terms by 2, we had x squared minus 3x minus 4. And yes, the red and blue graphs are different at every point except for 2. That's where it crosses the x-axis, our solutions. Because again, for this quadratic, we're trying to find out in either one of these, what values of x will make it equal 0? What values of x will make the y value be 0 if we graphed it? Well, if I look at the graph, does it give us 2 values of x that make the y value be 0? Well, yes. One of them is what? -1, and the other is 4. And those are our solutions. And again, neither one of them is the restrictions. Because when we graph these in the graphing calculator, second graph our table, we're looking for what values of x make the y value be 0. And we see for the one in blue and the one in red at -1, it's 0 for our 2x squared minus 6x minus 8 and x squared minus 3x minus 4. They both gave us the same values. So again, if we get a quadratic, it's sometimes good to try graphing it first, because if it's integer solutions, the graphing calculator will tell us them straight out. Questions on this here? Questions on any of this so far? Because the last one, because here, even if we didn't use the graphing calculator at this point, it is still solvable. Because here we can factor it to solve it. Because since the third term is negative, our signs are opposite. Factors of x squared are x and x. And the factors of 4 we want are going to be 1 and 4, not 2 and 2. We have two things multiplied together to equal 0. So according to our zero product property, one of them must be 0. And from here, subtract 1, telling us x is -1. Here we would add 4, telling us x is 4. Same solutions. the graphing calculator is sometimes a little bit quicker if we have rational solutions. This is the last one we're going to look at today. 5 over x plus 7 over 4 equals negative 9 over x. Now this time we have so the two places we have x in the denominator is, well, 5 over x and negative 9 over x, yes? Does the 4 have an x next to it? No, so is there any way we can make that 4 be 0? No. So the only places where we can actually have a division of 0 is the 5 over x and negative 9 over x. And in both of those spots, well, x is by itself, so x cannot be 0. Now we need to find our least common denominator, what we need to multiply everything by. So 4, because our 4 would multiply, and it would simplify out with the middle one, yes? X appears how many times? Twice. How many times does it appear in each of the denominators? We just need it once. Because if one of these had been x times x, then we would need it twice. Because when we do this once, I'm going to go on and actually, we're going to multiply instead of just crossing it out at the beginning. Because here we'd have 4 times 5 times 4x over x. Plus 7 times 4x over 4 is equal to negative 9 times 4x over x. And in our first one, the x and x would cancel. The middle, 4 and 4 would cancel, and the last one, the x and x. So even though x showed up twice, having it multiplied by once reduced all the denominators.
Are you timesing it? Is that what the dot is?
Mm-hmm. Yes. Questions? Yeah, so we have 20 plus 7x equals negative 36. So leaving it in our multiplication is helpful, especially for the middle, because our 4 and 4. Because 7 times 4x would be 28x. Then we would divide it by 4, giving us back to 7x. Because we could have just multiplied, especially at the start, and said here, the x and x cancel, here the 4 and 4. Here the x and x and gotten to the same spot. Now we just need to solve for the value of x. So what do we need to do next? Minus 20 from both sides. Which will tell us that 7x is equal to negative 56. Divide both sides by 7, telling us x is negative 8. Questions on any of this here? We'll finish this up tomorrow.